Okay, class, so we have here example number 14 as an example for your forces exerted by a liquid on a plane area. Okay, so here, as you can see, we are to determine the resultant force F due to water acting on a 3 meter by 6 meter rectangular area AB. Okay, so take note class that our fluid is water, which is the liquids, and we have here the area specifically, which is AB. So this is what our, or what area we are trying to solve for the force. Okay, now if you could recall, to solve for force, simply multiply the specific weight times the HCG times the area. Okay, now since our fluid is water, if you could recall the specific weight of water in SI unit. Why SI unit? Because our unit here are in SI units. So we will be using the 9.79 kilonewton per cubic meter. Okay, again, this value here is the specific weight of your water. Now, how about for the HCG? Recall class that HCG is the distance from your free surface to your center of gravity. Now, hindi buong etong area na to yung pinag-uusapan natin, but rather, etong area lang, yung AB lang. Okay? So, therefore, dito tayo mag-focus kung ano yung center of gravity niya or yung centroid na. So, obviously, this is a rectangle. Okay? And, based from our discussion, the center of gravity of a rectangle is just the half of its height. In this case, the height is 6 meters. So, obviously, this is the location of its center of gravity. Now, the question is, what will be the distance from the free surface? Now, in this situation, our free surface is right here. Okay? So, from this, going to this portion, so how much? Or how far is it? So, obviously, the half of 6 meters is 3 meters. So, looking at the measurement, so 3 meters plus 4 meters. So obviously the HCG here is 3 meters plus 4 meters. This is 7 meters. Okay? Now how about for the area? Again, our focus here is the area of AB. Rectangular area of AB. So from the shape of it, rectangle, how are we going to solve for the area? So simply length times width. So in this case, we are given here 3 meter by 6 meters. So obviously here, we are given already from the figure the 6 meters, which shows it's something height, okay, or something width. Now, or even length, something like that. So if we see through the three-dimensional area of this surface, so the 3 meters is right here. Okay? Ganyan siya. Can you follow? So this is 6 meters and this one is 3 meters. This width here. Okay? So obviously, all you have to do is multiply those dimensions. So 3 meters times 6 meters is 18 meters. And that's the area. So therefore, solving or substituting here, the force will be 9.79 kilonewton per cubic meter times your height or the distance, which is 7 meters, times your 18 meters. So using your calculator class, kindly solve. We have 9.79 times 7 times 18. We have 1,233.54. And what will be the unit class? Take note or notice that the unit meters will be cancelled. So, dalawang meter. By the way, it's 18 square meter. So, square meter times meter, this cubic meter. So, this will be cancelled, leaving us with the unit kilonewton. And that's it. This is the force acting on your area AB. Okay? So again, this is the answer for example 14. Now, how about for our example 15? Okay, for example 15, we have here the same given. Take note, class, we are given the same figure, but we are asked for a different force. Okay, take note that in example 15, we are to solve for the force in the area CD. Asan yung area CD? This is the area CD. This one. This one, this black line, this bold letter here. Okay? Now, how are we going to solve for the force since it is inclined? Okay? Take note that the same fluid, it is water, and we are given here 4 meter by 6 meter triangular area. Take note, earlier, the area AB is a rectangle. Now this one, triangle, it is a triangular area. So how does it look? Take note, the apex of the triangle is at C. So this is the C, this one. So that means, if you draw like this, okay, this will be our C, this is our D, okay, and how much? This is not our D, by the way, this is the D, okay, because in this case, class, this 6 meters here is our height, okay, this 6 meter is our height. So if we draw this, this is our 6 meters, this one, there. How about for your 4 meters? What is this 4 meter? 4 meters, class, is the base. That's the base here, 4 meters. Okay? Because, class, if you what do you call this? If you drew the three-dimensional figure of this, it will look like this, class. Oh. Ayan, pag ganyan siya. Okay? So, the apex is the C, and the 4 meter given here is the base. The 6 is the height. Okay? So, the same, class, we are asked for the value of your force. So, same formula. So, gamma times HCG times area. Now, for your gamma, we have 9.79 kilonewton per cubic meter. Now, how about for the distance from your free surface to your center of gravity? Now, take note, class, that we are dealing here with triangle. If you go back in our topic in triangle, what is the center of gravity, or what's the location of the center of gravity for triangle? The center of gravity from the apex, if you measure from the apex, it will be two-thirds of its height. In this case, our height is 6 meters. Okay? So which means that 2/3 of 6 meters is how much? That is 60 by 3. That is, kindly 12 divided 3, that is 4. Is it correct? Is it 4 times 6? Yeah, that is 4. Okay? 4 meters. So that means that this is 4 meters. Now, what will be the distance from your free surface? This is our free surface, class. Okay? So, by the way, this is meron tayong kulang dito, class. This is 3 meters, by the way. Kindly add the distance to this apex C is 3 meters. So therefore, we have to add these 3 meters to the location of the center of gravity of triangle, which is the 2/3 of 6, which is 4 meter. So still, it is 7 meters from the free surface. Okay? Now, how about for the area? The area, since it is triangle, will be BH over 2, or base times height all over 2, 1/2 BH. So in this case, our base is 4 meters and our height is 6 meters. So therefore, substituting, we have 24 over 2, or that is 12 square meter. Okay? So substituting, class, our values here, we have 7 meters times is 12 plus 12 square meter. Okay? So we will have, using your calculator, we have 9.79 times 7 times 12. So we have 822.36. And the unit, still this will be cancelled, and the unit left is kilonewton. Take note, this force is acting on area CD. Okay, so this is answer already for example number 15. Okay. Now, how about for example 16? Okay, wait lang. Okay, how about for example 16, class? Wait lang ha. Okay, we are now on example 16. This one. So example 16, we are given here this figure. Okay, and in this figure you can see that we have a tank A, B, C, D. This is the A, B, C, D tank, and there's a pipe connected to it. This one. So the question is, for letter A, determine and locate the resultant force acting on the area AB, which is 8 feet wide. Okay, 8 feet wide. So what will be the force here? Take note. Force, the magnitude, and the location. So the same, class, we will be using force is equal to our letter A, HCG times area. Now the question, the fluid is water. So the same class, we will be using the value of water. But take note, what unit system do we have here? So it is British engineering. So therefore, we have to use the value, which is 62.4. Kindly check. Was it 62.4? Let us check first. The value of specific weight for water is, 62.4 pound per cubic foot. Okay. So we have here 62.4 we have pound per cubic foot. Okay. How about for the HCG, or the location of your center of gravity? Take note that we are focusing on area AB. Take note, the width is 8 feet rather. Okay. Where is AB? This is AB, class. This is AB. This one. AB. Okay, so you have to focus on this side. Okay, and take note that the width is 8 foot, which means that this is 8 feet. Okay, so obviously this is how it looks like. 8 feet, and the height is 6 feet. By the way, class, the apostrophe here is a symbol for feet. Okay, so 6 foot or 6 feet by 8 feet. So obviously, to solve for its area, so we multiply the 6 feet and the 8 feet. So from here, area is 6 feet by 8 feet. There. So this is 48 square foot. Okay? So substituting, class, we have 62.4 pound per cubic foot times HCG is, by the way, we don't have HCG yet. Yeah, the location of your center of gravity from the free surface. Now, where is the free surface here? This is our free surface, this one. So from here, going to the center of gravity of area AB. So since this is rectangular, therefore the location of your center of gravity is right here, this one. So obviously, just half of 6 feet. So this one is 3 feet from here. So 3 feet plus this length here, so that this will be our HCG. Okay? So this is 12 feet, as you can see here. So therefore, 12 feet plus 3 feet is your 15 feet. So our HCG to locate your AB is 15 feet. And for the area, we have 48 square foot. Okay? So from here, class, force is, using your calculator, 62.4 times 15 times 48. We have 44,928, and the unit will be, this will be cancelled, and you'll have pound as your unit. So 44,928 pound. Okay? That's for letter A. Again, let's name this as FAB. Now, how about for letter B? What's the question for letter B? Compute the total force on the bottom of the tank. Take note, class. Force on the bottom. Okay, let us go back to our figure. Where is the bottom part of this tank? This one. So obviously, the bottom is this one here. If you complete the three-dimensional figure of this tank here, it will look like this. Okay, I'm sorry for that. This one. Okay, so where is the bottom part? So the bottom part, class, is this one. There. Okay, that one. So we are to determine the total force acting on that area. Okay, class? This area, we are referring to this area. Now, still using the same formula, F is specific weight times HCG times area. Okay, so still water is 62.4 pound per cubic foot. Your HCG class, again, is your distance, okay, towards your center of gravity. So since our area is this flat bottom, okay, so where is the center of gravity? The center of gravity is right here. This one, let's use red. This one, right? This one. But how are you going to locate that? It is at the very bottom. So that means that you really have to measure from here going to this. And that is how much? So take note that 12 feet and 6 feet. So you have to add 12 feet plus 6 feet. And that is obviously 18 feet. Okay? Now, how about for the area? Okay, again, we are trying to determine the location or the what do you call this? The force at the bottom. So therefore, you have to focus on this area here. This one. Okay? So what do you think is the area? So still it is rectangular. So again, this is 8 feet. This one, 8 feet. And this length is 20 feet. So therefore, 20 feet times 8 feet. Okay? So that is how much? 20 times 8 feet, 160 feet times. So 160 feet. Okay? And therefore, substituting here, we have F is 62.4 cubic foot times, we have 18 feet times 160 feet. And that is how much? 62.4 times, this is 18 feet, right? 18 feet times 160. 179. 62.4 times 18 times 160. So we have 179,712 pound. The unit is pound. Okay, so this will be cancelled out. So class, that's the solution for example 14 and example 16. For letter B. For letter B only. Okay, kind of screenshot. And how about for our example number, letter C, by the way, letter C. Compute the total weight of the water. Okay, total weight, take note. Total weight, class, as we know, can be solved by multiplying mass times acceleration due to gravity. Okay? But we don't have mass. Okay? We don't have the mass of our water. So therefore, how can we going to solve this? Now recall that your mass can be solved using density. Recall density is mass over volume, right? Now, do we have density? Because class, we can solve for volume. Okay? We can solve for volume. Wait lang ha. Wait lang, class. Okay. So, mass over volume. We can solve for volume. How? As you can see here, there, we have here the total volume by multiplying length times width times height. And since this is a rectangular parallelepiped, okay, volume can easily be solved times height. So our length here, as you can see, is 20 feet. Your height is 6 feet and your width is 8 feet. There. So we can have 20 feet times 6 feet times 8 feet. There. So 20 times 8 times 6, we have 960. 960 cubic foot. Okay? Now, our problem will be the density. We don't have the density of water, but you have, since water class, we already have our value for that class, right? For British engineering, we have the density, which is 1.94 slugs per cubic foot. And for the SI, we have 1,000 Newton per cubic meter. Kilogram. Now, since it's easier, okay, since it's easier for us to have, as you can see here, we have density is specific weight times acceleration. So, therefore, we can express here mass over volume. Instead of density, we have specific weight times acceleration due to gravity. Okay? So, therefore, in order to solve for mass, we can have specific weight times volume all over G. Can you follow? You cross multiply this and you divide by G there. So this will be the value that we will be substituting here. Okay, so to solve for weight, so simply mass is specific weight times volume over G times G. So as you can see here, you can cancel out the G, so you don't have to use it. So therefore, to solve for the weight of the water, so simply multiply the specific weight of water times the volume of water, which is in this case 960. So specific weight of water is 62.4 pound per cubic foot times your volume is 960 cubic foot. Okay, this is our weight already. So 62.4, using your calculator, 62.4 times 960. We have 59,904, and the unit class will be pound. So again, this is already your weight, total weight of water. Okay? So that would be the solution for your example number 16.